Mhm. All right, for those of you who are not physically taking this class, if you're not familiar with this sentence, which is what we did on day one, close to 2.5, 3 months ago, whatever it is, right? I suggest you look at the video on skills exponential evaluations. Right, so here's the sentence that we started with. That was the first thing that you saw in this class. The value of the exponent that you put on top of a 5 to get a 25. To get the quantity of 25 is a 2. And I asked you to write it symbolically because if that's the way we communicate mathematically, we're never going to get anything done because it took me too long to write that. All right, so many of you know how to do this now. What do you write when you say the value of the exponent? That's what a logarithm is. A logarithm is the value of an exponent. Lengthy way of writing a value, though, that you put on top of a 5. That's where the base goes. To get the quantity of 25 is equal sign a 2. And so if I wanted to find this quantity, I would rewrite it in exponential notation, and I would say 25 is 5 squared. And that's the inverse operation of a logarithm, is changing it to exponential form, and we're still working on that. A lot of people are still trying to figure out how to get from the log to the, to the answer when we don't give you the quantity. We've got to change it to exponential form. Right? And that's what we've been practicing in class. All right, so remember, in the exponential evaluations video, we looked at the 3 operations here: reciprocation, squaring, and cube rooting. And if I change this into exponential form, that's the exponential form. If I change it to logarithmic form, this is how it would read. And if we didn't know this answer, then we have to find it. How do we find it? We conceptually understand what that is asking. It's asking, what do I put on top of 8 to get the quantity 1/4? And that's what this side is asking. Okay, I've changed it to exponential form. And the rules of exponents require the same base. We could not simplify m to the 6 times n to the 3. Nothing we can do. But m to the 6 times m to the 3, yes, we would say m to the 9th. We'd be looking at our exponential rules. So we cannot talk about rules here unless they're the same base. And so what do the numbers 8 and 4 have in common? Well, 8 is 2 cubed, and we're going to raise that to the exponent of some type, equals 1/4, which with practice, I hope you already know, is 2 to the negative 2. So now that we have the same base, we can say that power to power is multiplication. Therefore, 3 times x has to equal -2, and therefore x is equal to, can you still see everything? Turn it down just a little bit more. X equals -2/3, which I think we started with up here. All right, so that's the practice we're going to do in this video. I'm going to give you some logarithms. You're going to put them in the same base notation and figure out what steps you take to turn this into that. And that's what we're going to do in a second. And the last one I hope you can look at and not have to put pencil to paper, but you can see the operation so you can just write the answer. That's our goal. All right, so let's do, I got 4 practice problems here. You pause the video. This is skill practice. So each time you pause the video, so the videos aren't too long, I'm just going to do them repetitively, one after the other, and not spend much time. All right, so you got to know the question being asked here. What's the question being asked? What do you put on top of a 4 to get an 8? We did one just like that a moment ago. So what's the common base? What do 4 and 8 have in common as a base? Multiples of, well, exponentiation base 2. So this is 2 to the 2 to the x equals 2 to the 3. Rules of exponents, 2x equals 3. Therefore, x equals 3/2. So on the side here, I will look and see if that answer makes sense. Does 4 to the 3/2 actually get us 8? Well, the square root of 4 is being cubed, and therefore 2 cubed gets gets us 8. So that was the exponent. Yeah, I guess I'm gonna have to erase a little bit here to keep getting some space. Next problem. Log 1/9 of 27. So I gotta get this in the same base. Looks like it's a base 3. So we're gonna write 1/9 as 1/3 squared equals 3. Well, how do I want to write this? 1/9 to the x equals 27. That's our first step, changing it into exponential notation. So there's the x that we're solving for. I know 1/9 is 3 to the -2, right? 9 is 3 squared. And we can show this exponent as a negative exponent, moving it into the numerator position. And I know 27 is 3 cubed. So therefore, minus 2x equals 3. X is equal to -3/2. 3 exponential operations: square rooting, cubing, and reciprocating. Doesn't matter the order we do it in. So let's check our answer by doing 1/9 to the -3/2, and let's see if that does come out to be 27. All right, so the minus sign means I'm going to reciprocate. That's a 9. I'm going to take the square root of 9, which is 3. And 3 cubed is indeed 27. So our answer was -3/2. Now let's try the next one. And we'll do the last one just conceptually. So 16 is 2 to the 4th. It's also 4 squared. So which one will we use? Well, we'll use base 4. All right, so the question is asking, the calculation here that you're performing is trying to find the exponent on top of 16. That gives us 1/64. I know 16 is 4 squared to the x, and I know that 64 is 1/4 to the 3. So therefore, I could have written this as 4 to the 2x equals 4 to the -3, right? That means to reciprocate, and you'd get that. So therefore, 2x equals -3/2, 2x equals -3, and therefore x equals -3/2. So let's look at these 3 exponential operations performed on the number 16. Let's see what we get. 16 to the -3/2. I'm going to do the square root of 16. That's 4. I'm going to do 4 cubed, which is 64 to the -1. That's 1/64. Oh, yes, bingo, that's what we wanted. Well, let's do the last one, see if you can just answer it without having to do any writing. See if you can figure out what you'd have to do to this number to turn it into that number. And then I'll come back and change everything into the bases in case you can't do it yet. So I see a reciprocation is necessary. I need to flip the switch, get that to be 25. I know I got to take a square root of 25 to get the same base in this problem. Now it's a base 5 problem, and I know how many times I have to multiply 5 times itself to get 125. So that's what you could have done if you got to the point of conceptualizing the process. You could have just looked at it and said, I need these operations. All right, so what do we have? We've got 1/5 squared to the what equals 125, which is 5 cubed. Now I have the same base. This is the same as 5 to the -2x equals 5 to the 3. So therefore, -2x equals 3, and x equals -3/2, which I hope we have over here. And indeed we do. So there's a little practice, something we've been working on for a while. And if you're still having trouble with it, well, could be because you're not getting enough practice. So you got to look at those answer keys every single test, and you got to see what your mistakes are and stop making them. That's the goal. Let's stop this one and upload it.